Yes students, good morning, Jai Swaminarayan. Welcome to our first video lecture of chapter number 9. Students, we are starting differential equation. So students, today we are going to start a new chapter after a very long time. Chapter 9, students, differential equations. Now students, all of you concentrate. How to define, students, a differential equation? Students, pay attention. Say, suppose I have an equation of this form: x square d2y by dx2 plus y dy by dx plus 7 is equal to 0. Students, all of you please concentrate. We are going to start with the definition of a differential equation. An equation involving independent variable x, dependent variable y, and its derivative with respect to independent variable x. An equation involving independent variable x, dependent variable y, and derivatives of dependent variable y with respect to independent variable x is called a differential equation. Check. This equation involves independent variable x, dependent variable y, and derivative of y with respect to independent variable x. Then such an equation, students, is called a differential equation. Once again, an equation involving independent variable x, dependent variable y, means y is taken as a function of x, and derivative of dependent variable y, derivatives in general of dependent variable y with respect to independent variable x, is called a differential equation. This is the best example. Functional representation is x, y, y1, y2, and onwards is equal to 0. It can have any ordered derivatives of y with respect to independent variable x. So this is the functional representation of a differential equation. This was asked as MCQ in which category? Which of the following is a functional representation of differential equation? So once again, an equation involving independent variable x, dependent variable y, and derivative of dependent variable y, derivatives of dependent variable y with respect to independent variable x is called a differential equation. Example I have written: x square y2 plus y into y1 plus 7 is equal to 0. The functional representation of a differential equation is f into bracket x comma y comma y1 comma y2 up to yn. This is, students, the functional representation of a differential equation. Then our textbook, students, has given the definition of an ordinary differential equation, students. A differential equation consisting of derivative of dependent variable y with respect to only one independent variable x is called, students, an ordinary differential equation. This is interesting. What is an ordinary differential equation, students? A differential equation where the derivatives of dependent variable y are considered with respect to only one independent variable x, then such a differential equation is called an ordinary differential equation. So this differential equation is an ordinary differential equation. X dy by dx plus y minus 7 is equal to 0. Because here there is only one independent variable. A differential equation where derivatives of of dependent variable y are considered with respect to more than one independent variable, such a differential equation, students, is called partial differential equation. This we studied in your engineering second sem. Partial derivatives, students. So, a differential equation where the derivatives of dependent variable y is considered with respect to more than one independent variable, then such a differential equation is called partial differential equation. In partial derivative, students, we have more than two variables, and by differentiating we take any two variables or one variable constant and differentiate one. That is above the scope of your book, students, so I am not able to explain at present because partial derivative is altogether a different topic. So let us summarize, students, these three definitions. Once again, all of you please concentrate. First of all, what is a differential equation? An equation involving independent variable x, dependent variable y, and derivatives of y with respect to independent variable x is called a differential equation. Then what is an ordinary differential equation? A differential equation where derivatives of dependent variable y are considered with respect to only one independent variable x is called an ordinary differential equation. Then what is partial differential equation? A differential equation where the derivatives of dependent variable y are considered with respect to more than one independent variables, then such a differential equation is called partial differential equation. That is not there in your syllabus. So whenever I write a differential equation, it means, students, ordinary differential equation. Now, the next definition is order and degree of a differential equation. The next definition, students, which I am going to consider is order and degree of a differential equation. Say suppose I write this d3y by dx cube plus twice dy by dx raised to 5 plus 3y is equal to 0. Say this is the differential equation. Now, first of all, students, we will focus on what is order of a differential equation. First of all, students, I am focusing on order of a differential equation. The order of the highest order derivative occurring in a differential equation is called the order of differential equation. What is the exact definition, students? Pay attention. Then the order of highest order derivative occurring in a differential equation is called order of the differential equation. Check on text in textbook page 380. Order of a differential equation is defined as the order of highest order derivative occurring in a differential equation. In this differential equation, this is first order derivative and this is third order derivative. So, order of this differential equation is because, students, the highest order derivative occurring in the differential equation is 3. The highest order derivative occurring in the differential equation is 3. Then what is degree of a differential equation? After writing a differential equation in a polynomial form, after writing a differential equation in a polynomial form, the power of highest order derivative term. Here the highest order derivative term is 3 and nothing means its power is 1. But I repeat, after writing the differential equation in a polynomial form of derivatives, whenever I refer the word polynomial, the power of derivatives can never be a fraction. After writing a differential equation in a polynomial form of derivatives, the power of highest order derivative term is called the degree of differential equation. This differential equation is already written in a polynomial form because all the powers of derivative terms are integers, especially positive integers, or we can say minimum 0. In constant term, the power of derivative is 0. Here there is no constant term. So after writing a differential equation in a polynomial form of derivatives, the power of highest order derivative term, here highest order derivative term is 3, nothing means its power is 1. So degree of this differential equation is 1. So while writing degree and order, one must be very careful, especially for mentioning of degree of a differential equation. A differential equation must be written in polynomial form of derivatives. Whenever I say polynomial, the power of derivative terms must be positive integers. So if I sum up these two definitions, order and degree of a differential equation, students pay attention. What is order of a differential equation? The answer is the order of highest order derivative occurring in a differential equation is called order of differential equation and its power. But whenever I consider degree, the first criteria or requirement is the differential equation must be written in a polynomial form of derivatives. Whenever I refer the word polynomial, power of derivative terms cannot be fraction, it should be positive integer. So after writing a differential equation in a polynomial form of derivatives, the power of highest order derivative is called degree of the differential equation. As per our example, the degree of differential equation is 1 and order is 3. So for mentioning degree, a differential equation must be written in a polynomial form of derivatives. Students, this we have to very carefully remember. Now students, next, now we are doing exercise 9.1. Students, now we are focusing on exercise 9.1, which we can do verbally for students, which we can do very easily. So this is not at all difficult, students. Let us write the sums. Exercise 9.1, question 1. I am writing 5 questions together, students. d4y upon dx4 plus sine of y triple dash is equal to 0. Okay, this is first sum. Second, y dash plus 5 times y is equal to 0. Okay. Third sum, students. ds by dt raised to 4 plus 3s into d2s upon dt2 is equal to 0. Okay. Fourth, d2y by dx2 the square plus cos of dy by dx is equal to 0. Fifth, it is d2y by dx2 is equal to cos of 3x plus sine of dx. Sixth, okay, let us do this pi sums first. Then we write the next pi sums. Okay, students, the logic of writing questions for order, a differential equation may not be written in the polynomial of derivatives. The highest order derivative is 4. So here order is 4. I am writing 4 for order. Now since this is sine of d3y upon dx3, so this is not in a polynomial form of derivative. Whenever a differential equation is not in the polynomial form of derivative, degree is not defined. So the question is like this, that we have to write order and degree if defined for the following differential equation. Mind you, sine of d3y by dx3 is not in a polynomial form of derivatives. So order is defined because the highest order derivative is 4, but students, degree is not defined. So degree is not defined when a differential equation is not expressed in a polynomial form of derivatives. Here, the highest order derivative is first order derivative. Its power is nothing but 1. So order and degree each are 1. Here, the highest order derivative is 2, and its power is nothing but 1. So degree is 1. Don't write the highest power. We have to write degree as the power of highest order derivative. So highest order derivative is 2 and its power is not given, means 1. So degree is not the highest power occurring in a differential equation. Degree of a differential equation is the power of highest order derivative term after writing a differential equation in a polynomial form of derivatives. Here, the highest order derivative is 2. So order is 2 and degree is not defined because when theta is as a derivative term, the differential equation is not in a polynomial form of derivatives. Here, the highest order derivative is 2, so order is 2 and its power is 1, so degree is 1. So order 2 and degree 1. So degree is not defined whenever a differential equation is not written in a polynomial form of derivatives. Means that you must very carefully understand as well as remember, students, that you have to very carefully, students, understand and remember. Okay, next for the set of questions, we'll start from sum number 6. Let us write the differential equation. It is y triple dash square plus y double dash cube plus y dash raised to 4 plus y raised to this. I'm not able to see this carefully. I think it is y raised to 5. Let this be 5 over 3. That doesn't matter. Okay, 7th y triple dash plus twice y double dash plus y dash is equal to 0. Okay, 8 y dash plus y is equal to e raised to x. Okay, 9 y double dash plus y dash square plus twice y is equal to 0, and 10th y double dash plus twice y dash plus sin y is equal to 0. Okay, students, then 2 MCQs will solve poorly. Okay, students, pay attention. Check question number 6. Students, pay attention and check question number 6. The highest order derivative, triple dash, is third. So order of this differential equation is 3. This is already in the polynomial form of derivative. So the power of highest order derivative term is 2. So degree is 2. Here, the highest order derivative is 3 and its power is 1. So order is 3 and degree is 1. Here, the highest order derivative is dy by dx. So order 1 and its power is 1. So degree 1. Here, the highest order derivative is 2. So order 2 and its power is 1. So degree 1. Here, the highest order derivative is 2 and its degree is 1. So, this is very easy, students. Once you understand, you can say this type of questions you will love to do. And trust me, students, these questions are asked in exam for, you can say, 1 mark. Now 11, students, you can refer the textbook for the question. It is y2 cube plus y1 square plus sine of dy by dx plus 1 is equal to 0. Whenever in theta we have derivative term, differential equation is not in a polynomial of derivatives, so degree not defined. So the correct option is D. And definitely order is 2. In the 12th step, the highest order derivative is 2, so the order of differential equation is 2 and its power is 1, so degree is 1. So students, exercise 9.1 was merely, you can say, an objective based. We don't have any calculations for the exercise 9.1, but fundamentally, students, it is involving the definitions, and your definitions must be very, very clear, students, as far as this topic is concerned. Students, definitions must be very, very clear, students, as far as this topic is concerned. Now, the next topic is, students, general and particular solutions of a differential equation. Students, all of you pay attention. General and particular solution of a differential equation, students. Now, all of you consider, let us do this with the help of an example, students. Now, general and particular solutions of a differential equation or equations. Now, students, all of you pay attention because this topic demands some extra care. Say I have, let me take the example as given in textbook. Say I have a differential equation as d2y upon dx2 plus y is equal to 0. Say this is any differential equation. Now I have a function y is equal to a sine of x plus b, where a and b are arbitrary constants, means real constants. All of you students pay attention. Again, these two definitions are also an integral part of the chapter. What do you mean by a general solution and what do you mean by a particular solution, students, of a differential equation? Now, say I am given a differential equation. and I am considering the function y is equal to a sine of x plus b. So this is a function fx. Now if I differentiate and write dy by dx, what I will get? A cos of x plus b. And if I take second order derivative, then this will be minus a sine of x plus b. Now what I am doing, I am substituting this y and d2y by dx in the differential equation. In the left hand side of the differential equation, left hand side is d2y by dx2 plus y. What is second order derivative? Minus a sine of x plus b. What is y? A sine of x plus b. This two gets cancelled and I am getting my right hand side as 0. So a function along with its derivative, when satisfies the differential equation, a function along with its derivative, when satisfies the differential equation, is called a solution of differential equation. And specifically, here a and b are arbitrary constants. Constants are not given any values. So, a generalized function having arbitrary constants which satisfies the given differential equation is called a general solution of a differential equation. So, a function along with its derivative, when satisfies a differential equation, then such a function is called a solution of differential equation. In that function, when constants are generalized, such a solution becomes general solution. Now if I give values to a and b, suppose I write y is equal to 2 sine of x plus pi by 3. Then my a is 2 and my b is pi by 3. I am specifying the values of the constant. So when the values of the constant are specified in the solution, then such a solution is called particular solution of a differential equation. The solution which contains arbitrary constant is called a general solution of the differential equation. And the solution where the constants are given particular values is called a particular solution of differential equation. So remember three definitions. What is the solution of differential equation? First, a function along with its derivative when satisfies the differential equation, then such a function is called solution of differential equation. A solution which contains arbitrary constants like a, b, which we have written here, is called general solution of a differential equation. And when arbitrary constants are given particular values, then this solution which I have written, y is equal to 2 sine of x plus 3, is called a particular solution of differential equation. So in general, students, we have to study three definitions here. Once again, a function along with its derivative when satisfies the differential equation is called a solution of differential equation. Then a solution having arbitrary constants is called a general solution of differential equation. A solution where arbitrary constants are given particular values based on initial condition, then such a solution is called particular solution of differential equation. So I hope, students, this is crystal clear. Solution, general solution and particular solution. These three definitions must be very clear, students, when you study the exercise 9.2. Now students, I am going for two sums of exercise 9.2. In each of the exercise 1 to 10, these questions 1 to 10, verify that the given function is a solution of differential equation, corresponding differential equation. So how can I say that this function is the solution of differential equation? When a function along with its derivative satisfies the given differential equation, we can say that the given function is a solution of differential equation. So exercise 9.2, sum number 1. What is given function? Given function is y is equal to e raised to x plus 1, and given differential equation is y double dash minus y dash is equal to 0. Students, we are to verify that the given function is a solution of differential equation. What I will do? I will find derivatives required. So I start with the function y is equal to e raised to x plus 1. So y dash will be e raised to x, y double dash will be also e raised to x. Yes or no? Now there are two ways to do the sum. First, in the LHS of differential equation is y double dash minus y dash, and y double dash is e raised to x, y dash is e raised to x, and I am getting 0, which is RHS. So y is equal to e raised to x plus 1 is a solution of differential equation. This is the first way to prove or verify. We have not proved, we have verified. The second way is like this, that from this I am taking this as result 1 and result 2, then I can say from 1 and we get y double dash is equal to y dash, or y double dash minus y dash is equal to 0. So if from the function after differentiating we develop the differential equation, then also students I can say that this function is the solution of the given differential equation. So basically students, there are two ways to verify the given function is the solution of differential equation. First you find the required derivatives, start with LHS of differential equation, get RHS. So it is verified. Second, from the given function if I develop the differential equation, then also students we can say that the given function is the solution of given differential equation. Both the ways we can do the sums, so do not worry. Okay, let us do the second sum.